Hi everyone. I'm going to be going over question number 3 from the Chapter 8 Bingo Problems. This problem has to do with these three objects here who are within this XY coordinate plane. And it says that A, B, and C are moving, as we can tell with these vectors. And it says find x and y components of the net momentum of the particles if we define the system to consist of objects A and C, part B, which is B and C, and then part C, which is all three together. So once the net momentum, so the first thing we're going to need to do is we're going to need to break each object movement up, each momentum, into the x and y components. So let's start with A. And I'll do them in their own color just to try and keep it all separated. Hopefully that'll help keep it organized. So for part A, we know, first of all, that P equals mv, right? Well, momentum equals the mass times the velocity. And we're given all of that information. I actually realized I forgot to write down the velocity for B. Going 10 meters per second. But anyway, so we're given all that information, which is good. So now what we need to do is break it into components. So part A, or object A, we know that P, we'll say sub AX, equals, and we can tell that A is only moving in the y direction. And because of that, we know that there's going to be no momentum in the x, since it's all purely y. So the momentum in the x direction of A is just 0. So that'll be good for the future. So we'll just use our units, kilograms times meters per second. Now we'll do y. So P AY equals, and we know that it's m, which is going to be 5 kilograms, times 11, since that's the velocity. Now, one thing that we need to keep in mind, though, is that since it's in the negative y, we need to make sure that it's negative. So when we put all this into our calculator, or I guess we don't even really need a calculator, it just ends up being negative 55. So what I'm going to do is I'm going to write these out of the way because we're going to run out of room very quickly. So I'll just write these up here. So P AX equals 0. And P AY equals negative 55. Okay. So we know the components for part A, or for object A, and now we need to find it for B. So this one, since there is an angle which is given, we will need to figure that out. So we'll do X first. So P BX equals, and it's going to be the mass, so 6 times. Now, since we're looking for the x, we need to use cosine. So it'll be cosine of 60 degrees. And so, but also we need, I forgot to add in the velocity, which is really important. So 6 times 10 cosine 60. Perfect. So when we do that in our calculator, we end up with PBx equals 30 kilogram meters per second. So now we'll do the same thing with y. So P By equals the mass, which is still 6, times 10. Since it's the y though, we'll need to use sine of 60 degrees. So when we plug that in, we end up getting 51.96. All right. So 2 down, 1 to go. So now we'll move on to object or particle C. I'll just leave these units off. They're all the same unit, so just to keep everything organized. So now what we need is to do the x for particle C. So P C x equals, once again, it's going in the negative x, kind of like part A with the negative y, so we'll need a negative. The mass is 10. And then the velocity is 3 meters per second. So that ends up being negative 30 kilograms meters per second. So that's x, and then the momentum in the y direction is going to be 0 because there's nothing going in the y direction. So that's it for all of our different components. So we'll write these up. So P Cx equals negative 30 and P Cy equals 0. So now that we know our different components, now we can really get to the main part of the question, which wanted to know, it said find the x and y components of the net momentum if we define the system to consist of A, so we'll start with A and C, and wants the components. So since we've already figured this out, really this is easy. We just add them together because it wants the net momentum. And so for the x component, so we'll just say P x equals, it's going to be the ax component, which is 0, plus the c component, which is negative 30. So when we add that together, it's just negative 30. So that's the x component, and now Py, the momentum of the net momentum of the y components is going to be negative 55 here plus 0. So that just equals negative 55. So that's it for part A. So like I said, it's pretty easy at this point. We just add stuff together. So now part B wants the net momentum of B and C. So we'll just do the same thing. So P, so B plus C. We'll just use these same things because we're done after this part. So since we're not going to need to use these variables together, we can, it's not that big of a deal. So the x component of the net momentum is going to be 30 plus negative 30. When we add those together, it's just 0. The y component is going to be 51.96 plus 0. So we get 51.96. And that's it for part B. Now part C, it wants all three. So A, B, and C. So we'll say P x and P y. So the net momentum of x is going to be 0 plus 30 plus negative 30. So that's just going to be 0. Py is going to be negative 55 plus 51.96 plus 0. So when we throw that in our calculator, we end up getting negative 3.04. And that's it. So now we've solved all that it wanted. So hopefully you learned a little bit about breaking up the momentum into the x and y components, and then being able to find the net momentum through adding those components together. So as always, thanks for watching, and I'll see you in the next video.